So for 1-12, we're actually going to use the homework e-tool that was provided in the curriculum. And so I'm just going to not talk anymore and we'll play the video. Here we go. So hi there, this is the Desmos homework e-tool for number 1-12. And I really like these e-tools. If you are somebody who has not ever clicked on these links, they're actually really helpful and they get you started with this problem. So I'm just going to go ahead and take a look at this problem. Number 1-12. Junior is saving money in his piggy bank. He starts with 10 cents, which is our y-intercept, which you can see right here. Starts with 10 cents and adds 2 pennies each day. And it says create an XY table and a graph for the function for which X represents the number of days since Junior started saving money and Y represents the total money he has saved. So they've already started with 2 different points that they have plotted. And they haven't come up with an equation, but we're going to come up with an equation as well. So that will help you understand a little bit more. I start here. This is my y-intercept. It means I haven't started saving. I've started with 10 cents for Junior, and that is 10 cents. So 0 days, 10 cents. Then each day he adds 2. So we go to day 1, and you notice they've got the labels on the axes here. The x-axis represents number of days. The y-axis represents the total amount saved. So day 1, after day 1, he has 12 cents. So I'm going to go ahead and just fill in this table a little bit. We're going to have 3, or not 3, I'm going to go 3 or 2, and then I'm going to add 2 cents. So that's 1-4, okay? I'm going to come down here and I'm going to go 3. And then I'm going to add 2 cents. So that gives me 16. If you notice, I'm doing a rise over run of up 2 over 1, up 2 over 1. So I'm just going to finish out this table. 4, 18, 5, 20, 6, 22. So this, I already know what the line is, and some of you are already probably just chomping at the bit to actually put the equation in. This is a linear equation, and technically we wouldn't need any of the information that comes before here because you're not going to have a negative, you're not going to go backwards. But let's just go ahead and come up with our equation. So we know that our y-intercept is 0, 10. So that means 10 is going to be our equation. And we know that we're going up 2 over 1 because we're adding 2 cents each day. So that equation is going to be y equals, and then it's going to be 2x. And that's because it's 2 cents per day, and x represents the number of days. But we started with 10 cents. So we're going to add 10. And 10's our y-intercept. And that shows you how we can come up with an equation, a linear equation, from this particular problem. All right, we're moving on. Hey, so this is 1-13, and it says to use the zero product property. This is used a lot with quadratics. In fact, it's always used with quadratic functions and parabolas and different equations. But basically what it is saying is, how do I use this zero product property on these types of equations? Well, anything times 0 is 0. So what they want you to do is find out what's going to make 2x plus 3 equals 0 and 3x minus 7 equals 0. So the easiest way to do that is to just set 2x plus 3 equal to 0. Subtract 3 and divide by 2. So that means if this x value here was -3/2, that particular set of parentheses would equal 0. And so the solution for that, and that's what it is, zero product property, is talking about the solutions, and they also call it a 0, is -3/2 for that particular set of parentheses. So we would do the same thing for 3x minus 7, so we might as well finish that one. So you would add 7 and divide by 3. So those are your zeros. So if I am kind of giving you what the solutions are, those are the zeros, the solutions for that particular problem. Okay. Now, another thing you need to know, I am only doing 4 of these, of the 6 problems because I saw some interesting things that I thought maybe you would need some review on. And I'm not sure how much time your teachers are going to have in class to be able to help you with the review. So I'm going to go ahead and do that with 4 of these so that you can do the other 2 on your own. If you're assigned this, obviously. So we'll see how much you're assigned on this, but this is what I'll have. Okay, for this next problem, we've got to do a little review, and I'm hoping this is review. I just know a lot of you are coming from geometry, but the standard form of a quadratic equation is ax squared plus bx plus c, okay? And that's what we're going to be using here for this particular problem to help you understand how to factor it, because we're going to factor it so we can get it into the form of the 2 sets of parentheses for this particular thing. This is called the diamond method in my world. That's what I use all the time. You'll find that when the leading coefficient is 1 for this any equation, it's a lot easier just to use the diamond method. I have another example later that I'll work with where the coefficient is not 1. But on this one, we're looking at what A, B, and C are. So I can actually use this diamond method. So A in this case equals 1 because what I've already put here, okay? B equals -2 and C equals -35. So when I'm doing the diamond method, I want to put A times C in the top box, and I want to put B below. And this is just a graphic organizer to help you factor anything that's a leading coefficient of 1. Now, if you can't factor it, then you're going to have to use the quadratic formula, but these are factorable, and I want to be able to teach you that and help you with that. The quadratic formula is something else down the road. And you can look at the 1.1.4 lesson notes and you will see the quadratic formula. But most teachers are not going to let you use the quadratic formula for things that are factorable because it's really important to understand how to factor before you move on to tougher concepts. So my A times C in this instance, though, if I'm looking at that, here's my A and my C, that's going to be a -35. So I'm going to go ahead and write -35 in here. My B is a -2, which you see right here. So I'm going to put -2. So what I have to do is come up with 2 numbers that multiply to -35 and add up to -2. Again, 2 numbers that multiply to -35 and add up to -2. So I could do all kinds of things. I know 7 times 5 equals 35. But if you look at that, 7 times 5 is not a -35, okay? And 7 plus 5 is not a -2. So that means one of these has to be negative. So I'm going to go ahead and put a negative in front of my 7. And so then I'm going to look at it again. -7 times 5, that does equal -35. -7 plus 5, that equals -2. So I have found my 2 numbers. So all I'm going to do when I come down here to break them into parentheses is write x minus 7 and x plus 5. If I was to re-multiply those back together, they would equal the equation that we started with, x squared minus 2x minus 35. But now what I need to do is figure out what are the zeros? What is going to be my x value? So I'm going to go ahead and I'm just going to say if it was 7, x equals 7 because 7 minus 7 is 0. And then here, x equals -5 because if x was -5, -5 plus 5 equals 0. Now, I'm going to show you a quick graph of why that's important for down the road. So hang on just a second. So you will see here that I have added a graph of this particular function. And one thing that's really important, and you're going to learn this later, is this is a parabola. And you may have already learned this, but this is review. So it's parabola and a quadratic. They're both the same, but the solutions are where the graph intersects the x-axis. So if you take a look at this, this is our -5, and this is our 7. And so that helps bring home a little bit about what this equation is about and how important it is. So remember, you can always rewind this video and watch through this portion because it's really going to be important for you to be able to eyeball a quadratic and factor it, especially if the leading coefficient is 1, as it is here. So let's move on to 2 more examples on this one. So here are a couple more examples that I wanted to work from. Normally I wouldn't give you 4, I might look at half of them and try to figure them out with you, but there's just some that look a little different. And again, I'm trying to help you review and get some of these skills firm before you move on, because there's going to be some tricky stuff in Algebra 2. So first thing I do is, remember it does say on here, use factoring when necessary to solve. So we are going to have to use factoring. So when this is different because it doesn't have a constant, like this has a -5. This basically is +0. So you really don't have a constant there, but you can look at both terms and figure out what can I pull out that is common to both. And let me go ahead and erase this 0 so it doesn't cause any confusion later. All right. They both have x in common, so I'm just going to pull an x out. That means that what's left in my parentheses, because if I've taken an x away from x squared, I will have an x. If I've taken an x away from a -5x, I will have x minus 5. And that's how you're going to factor those out. But then you have to look at what causes them to be 0. What is going to be the solution? Well, if I'm looking at this one, the only value that this can be is 0. So that x is a 0. And then the only value here is x equals 5. So let's take a look at a picture of the graph of this. So here's a picture of this particular equation's graph. And you can again see this is 0. So it crosses at the point of origin. So that's why we know that one is correct. And then this one is 5 because it's halfway between 10. So you've got x equals 0 and x equals 5, and those are the solutions for that particular equation. So that just helps you back up your answers once you're factoring and finding the zeros. So let's move on to this next one. Okay, so this last one for 1-13 is a little trickier because it does have a leading coefficient that is not 1. But we're still going to use our diamond method, and I'm still going to put an A and this A times C up here and a B. We just have a few different things that we have to do for this one. So A times C in this case, remember our A equals 3, our B equals 14, and our C equals -5. So our A times C is going to be -15, and our B is going to be a +14. So how can I get two numbers that multiply to -15 but add up to 14? Okay, so I know it's going to be a pretty big number, so I'm just going to go ahead and I'm going to put in 15 and 1. Well, 15 times 1 equals 15, not negative. Okay, and then 15 plus 1 is 16. That means I need to make one of them negative. So I'm going to go ahead because I noticed that my 14 is a higher value positive. I'm going to make this a negative. Well, 15 times -1 is a -15, and 15 plus a -1 is a +14. Yay. So now what I'm doing here, using those numbers, this is what I'm going to do. So I have this 3x squared plus 14x minus 5. What I'm doing is using these two numbers to break apart 14, okay? And it really doesn't matter what order you put them in, but I'm breaking it apart. It's what you would get if you were multiplying two binomials and you had a middle term and you had to combine like terms. So I'm going to rewrite it as 3x squared. I'm going to put 15 because I know 3 goes into 15. So I'm going to put that first. So 15x minus x minus 5 equals 0. So basically, if I was to recombine these, it would equal the +14. So that's one of the reasons I'm doing this. So let's get rid of that because I also do some other stuff with this. So what I go ahead and do then is I factor each half of the equation. All right, so I'm going to put a vertical line in the middle. And this is called factoring by grouping. So I'm grouping basically. And so I am now going to look at this half of the equation and figure out what can I pull out of both of those. Well, I can pull out a 3x, which leaves behind an x, because 3x times x equals 3x squared, okay? Then I'm going to pull out a 5, or I'm going to have 5 left, because 3x times 5 equals 15x. So I have those 3. So I know what that is. So now I'm going to come over here. I'm going to factor the other half. Well, what can I take out of both terms for that one? Because I still need a spot here filled, so I have my second set of parentheses. Well, I can take out a -1. So I'm going to put a -1 here, which means -1 times what equals negative x? Just positive x. And a -1 times what equals a -5? A positive 5. So you'll see what I'm doing right here. So I can only have this set of parentheses, they can only be a factor once. So I'm going to go ahead and write down x plus 5 down here. But then I'm just going to go ahead and cancel that out because I want to see what's left. Well, what's left? I have a 3x and I have a -1. So that's my other set of parentheses, okay? Now, that means that x has to be an equal to a -5 to solve for this one. And when I do the algebra for this, add 1 and divide by 3. So that means it's 1/3 and -5. That's the solutions for this particular problem. Let me get you a quick picture of this graph so you can see how they line up correctly. Hold on. All right, so here's a little picture of the graph. Again, we have x equals -5 right there. And then look here, there's our fraction, 1/3. Now, these can be found also on a TI calculator, which you'll be using in class, but that'll come at another time when I explain how to do those on a Texas Instrument. So that ends 1-3. You can do the other two by yourself because I've given you enough information to be able to solve those. So moving on. So when I started this one, I took a look at the different inputs and outputs that they've given me on this particular problem. And then what I did is I took a look and I built a table of values so that they gave me input output. So 3 is input, 8's output, 10 input, 29 output, 20 is input, and 59. Well, I thought, okay, let's play with the 3 and the 8 really quick. So I thought, well, 3 squared, oh, let's get a better color so you can see it. I thought 3 squared is 9 minus 1 would equal 8. Okay, that works, but I got to try it on another value. So I went 10 squared minus 1. Well, that does not equal 29. So the rule I came up with was wrong. So I got to figure out a different way. I still like this information, but instead of using 3 squared, I used 3 times 3 minus 1 equals 8. So in a sense, it'd be 3x minus 1 equals 8, and 3 is my input, so then my output would be 8. So I thought, let's try that with the 10 and the 20, the 10, 29, and then 20, 59. So 3 times 10 minus 1, well, that does equal 29, okay? And then 3 times 20 minus 1, that does equal 59. So I have found a rule for my equation. So my function, because they did say this was a function machine, I would make it as f of x equals 3x minus 1. If I do that, I'm going to end up with a graph that is linear. So I can connect all of these points, and those are the 3 points that they gave us. Now, it asks, what would her machine do to the input of 5 or the input of -1? And what about x? Making an input-output table may help. So I am now going to let you finish that because I've given you the function equation, the rule that works for those 3 points. So now you can plug those in and solve for the output for 5, the output for -1, and the output for x. And hopefully that helps. Moving on. So on this one, they've actually given you everything to solve for the line. They've told you that the slope is 5. They told you that the y-intercept is 0 and -2. You have everything you need there to put together a linear equation, okay? Then what I would do, and so if I did that, I'm going to go ahead and so mx plus b, right? So my slope is m. M is my slope, and b is my y-intercept. So my equation would be y equals 5x minus 2, okay? Now, the other thing that they ask you to do here is to find the value of x when y equals 0. The easiest way to do that is to set the equation to 0. Then add 2 and divide by 5. So I have graphed over here this linear equation that goes with the part A. If you take a look at it, where is the y 0? That would be at this point. Well, that is approximately 2/5. So that's how you work this. If they're asking you to find the x value when y equals 0, you're basically finding the solution for this, the x. Okay? That's it. Let's move on. So in this problem, I'm not going to spend a whole lot of time going through this because I think everybody that's watching this video can actually handle it. But I will go ahead and just remind you. They're asking you each of the following equations, what is y when x equals 2 or when x equals 0? These are your inputs. So all you're doing is substituting them for the x values in each of the equations and giving the y value. And I would help you with that, but I'm pretty sure everybody can handle that. And this is not about me doing all of the work. So this one I think is good. Take that information I've given you and we're moving on. Okay, so for this particular problem, I'm not actually going to solve all of them. But there is one thing that I always worry about with this particular equation, and that's when students plug in that value that's negative and they're not careful and they just trust the calculator to plug in that value. And so remember, you have to put parentheses around a negative when you're squaring it. So that is 16 minus 8 plus 1. That would be 8 plus 1, which is 9. Okay? That's how you're going to solve that when you're using this particular function. But I am going to show you on the graphing calculator why it's so important to put the negative numbers into parentheses. So here we go. Okay. So I wanted to show you, I'm going to go ahead and put this equation in. It was a negative x, or it was x squared plus 2x plus 1. But what we're going to do is we're going to just plug in negative 4, because that's the value that we tested, squared, okay, plus 2 times negative 4. And don't forget, this is a negative, not subtraction. And then plus 1. And we get the answer negative 23. Well, what I'm going to go do now is I'm going to show you, first off, I want to make sure that I've set this, so second table set. I'm going to scroll down here because this is how I know I can put in the value I want to test. I'm going to make the independent variable ask instead of auto. Very good. So then I'm going to go to y equals, and I'm going to plug in the equation x squared plus 2x plus 1. Okay. And then I'm going to hit, I'm not going to go to the graph. Well, we could do the graph so you could see what it looks like. Okay, there's the graph. But what I'm going to do is I'm going to go to the second table. See how there's no values in there? Well, I want to test the -4. And if I remember, like, let's go back really quick. And we see that it says -23. Well, let's go check our graph. So second table, I'm going to plug in -4 and see if it's -23. It is not. It is supposed to be 9. And I already know the reason why it's like that. So let's take a look. Order of operations is done this way. They do the exponent first. So this would be a -16 minus 8 plus 1. Okay, and so that is where you get the -3. The correct way to do it is to put -4 in parentheses, then square it, plus 2, again, times -4 in parentheses, plus 1. And then we get 9, and that is the answer that we are looking for. So be very careful about how you enter your values into the calculator. And that ends that. So like I said a little bit earlier, I'm not doing all of them. You can go ahead and plug in the 3, and you can plug in the -22.872. You can also do it. You can do it by hand or do it in the calculator, however, but it might be also cool for you to try to figure out how to enter it into the table yourself. So you can go back and look at that other little video that I have there and see if that helps you. And then you just plug in those two values instead of a -4 to see what your answer is. Okay, moving on. So on this particular problem, it says, does the temperature outside depend on the time of day, or does the time of day depend on the temperature outside? In my eyes, the temperature outside depends on the time of day because it's obviously warmer during the day and cooler at night. So if it's daytime, we expect it to be warmer. If it's nighttime, we expect it to be cooler. But this gets into a discussion of independent versus dependent variables. Dependent variables are variables that, once something is plugged into something else, determine what that ends up being. So if we're looking at A, and I'm not going to answer this as here's the answer to letter A, here's the answer to letter B, and here's the answer to letter C, but I am going to talk a little bit about it. So I'm going to say if I've got y equals 3x minus 5, this is my independent variable. And that's because I have to figure out what that is to plug it in, and then it determines y. So it's determined by x, which means y is the dependent variable. So in this equation, which one is, in the time of day, temperature, or time of day, which one's dependent? Well, the dependent is the temperature. Time of day is independent, and temperature is dependent because it's determined by the time of day. So if I was to label an XY axis, so let's say this is our X axis, and this is our y-axis. But if I was to worry about whether it's temperature or time of day, remember, temperature is determined by time of day. So my axis would have time of day on the x value, and then it would have the temperature on the y-axis. How you put that information on there and what scale you choose is based on how you're looking at it, but that is the way I would look at that. Time of day on the x, temperature on the y, and then you have the rest of the information for this problem. Moving on. So this problem says Jill needs to cut a piece off of a 30-foot length of lumber. Well, however much she cuts off, the rest of 30 feet is what she has left. So recommendation here was to put this into table form to see if you can come up with the values. Well, if I'm going to go ahead and label this table because we're supposed to come up with a graph also. I'm going to say this is the number number of feet that have been cut. And this will be the number of feet. Well, let's just do that with number. Number of feet left. So one of the reasons this doesn't go on forever in either direction is because you only have what you have and you can't go negative on what you're cutting. So if I have 0, and let's just use a different color here, 0, 30 would be at the most what I would have. If I didn't cut any off, I would have 30 feet left. But if I use it up, it's going to end up being 30, 0. So you've got 0, 30, and 30, 0. Well, that's a pretty good linear equation. So I would say it's also a negative slope because of the direction it's going in. So I would give this an f of x. We have a y-intercept of 30, so we're going to say plus 30, right? But every foot is a unit, so it's going to be negative x. So it's going to be a negative 1 plus 30 equals 29, a negative 3 plus equals 27. You're going to have a negative, it's going to end up being a negative 24 that you put in, and it gives you 6 left. And that gives you an equation for this particular problem. So this particular problem actually asks you to fill out a table. So if I'm looking at this, and I'm going to be careful with my math, but I'm going to go f of 2. I'm not doing 0 because I already know that 0 when it's put in is going to be 0. But f of 2 equals 1/2 2 squared. Well, 2 squared is 4. So f of 2 is going to be 1/2 times 4. So f of 2 will equal 2. So I can put 2 in here, okay? F of 4, I'm going to put a line here. F of 4 equals 1/2 4 squared. Well, 4 squared is 16, and half of that is 8. So I'll have 8 there. Then f of 6 is 1/2 6 squared. Well, 6 squared is 36, and 1/2 of that is 18. But there's some values that are missing here that are kind of important. So let me show you a picture of the graph as it stands now with what we've got graphed. So if you look at this graph, right now we have all of these points, but we're missing everything on the left as well. So this is not a complete graph by any stretch. We still need to do a -2, a -4, and a -6. Okay, so we're going to start by doing that. I'm going to get rid of this diagram real quick because we're going to fix that. Okay, so I got rid of that graph, and now we're going to figure out. So I have f of -2, and this is one of those ones I warned you about. You've got to put parentheses around the -2 before you square it. Well, the -2 squared is 4. 1/2 of 4 is 2. So if you start to see a pattern here, f of -4, same thing, 1/2 times -4 squared. Well, -4 squared is 16, half of that is 8. So I'm just going to go ahead and follow these patterns. Okay, and then I'm going to put together a diagram that has all of those. Let me show you that. So now you can see how I have the new points graphed in a different color. This is a parabola. So if I was to put this equation into a calculator, it would be a parabola. Let's see if I can draw this. That's decent. And I missed that point and that point. You're getting the right idea though. Okay, but if I was to draw that put that equation, this one right up here into the calculator, that's what I would end up getting. Now, another question is, describe all possible input and output values. Well, all inputs are the domain. And so the domain on a parabola, regardless of whether it's pointed up or pointed down, whatever, is all real numbers. So all real numbers, which can also be all real. That's kind of the way I do it. All output values are range. And all you have to do about range on this one, because the minimum is at the point 0, 0, is to say that y is greater than or equal to 0. And that helps you with that problem. Moving on. So I will be showing a little bit of a Desmos activity with this in a moment, but and it'll be pretty self-explanatory on when you add a 3 or a -3 into each of these functions. But I'm going to go ahead and I'm going to do a couple of the other ones, because these are all essentially the y values that they're asking you to find. And you can graph and find them from graphing, but you can also find them algebraically. So g of x equals 8. That means this function I can substitute in. So I'm going to change it to 2x squared minus 5 equals 8. I'm going to add 5. Then I'm going to divide by 2. But then I'm going to take the square root, plus or minus the square root of 13 over 2, because that's how I get rid of this exponent. So x will equal plus or minus the square root of 13 over 2. Now, in units later in the year, square root of 13 over 2 will not be an acceptable final answer, but it's actually going to be okay for this particular problem. I'm going to solve one more, because then we're going to end up putting them into the tables so you can see how they work on the Desmos activity. So you'll get a little bit more, a better feel for it. So the same thing, g of x equals -7. So what I'm going to do now, again, is substitute it in. We're going to add 5. And then we're going to go and divide by 2. So that is not going to be a real answer. So you will not have this in your table, because we cannot do a square root of -1 at this point. It is it's an imaginary number, so non-real. Okay, so let's go to the Desmos activity so we can finish the rest. So here you have both functions graphed on the same graph. So just so you can see, the red line is your f of x function, and the blue parabola is your g of x function. And so you can see here they've got, when they plug in for the f of x 1, they end up with 2 1/3 for their answer for y. And then you have on the blue function where they've plugged in a 1, and it equals, so 1 is here, so pay attention to the scale here, it equals a -3. All right, so we're going to calculate some of those that same way. So f of 3 will go into the red table. So what I'm going to do is I'm going to go over here and I'm going to look for 3 on the graph. There's my x, f of 3, and I'm going to take it up to 1. So I'm going to go ahead and plug in 3, and that gives me 1, okay? And we can calculate that. Hopefully you're calculating that off the side. I'm not solving all of them that way, so that's another reason for you to do that yourself as well. So f of x for b was -5. So if I take a look over here at let's see here, f of x equals -5. So that means I'm looking for my y value to be a -5. So if I come over here on the red, and I come down here to -5, and I go all the way over here, it is 12. So I can come to the f of x graph, and I can type in 12, and it will give me the -5. But you can also do that algebraically by setting the equation equal to the -5. Then we're going to come down to, we calculated a couple of these. G of -3 is, so if we go to -3, that's right here, it's going to take me all the way up to, let's see where it takes me. G of -3, all the way up to, it looks like 13. So let's type in 13 and see what happens. Or no, -3. and see if we get the, yep, we were right. So we looked at our graph that way. That one was fairly easy because we're just typing in the x value. Now we need to go and look at where does g of x equal -7. We solved this algebraically and we found out it was not real. So let's go see if we even have a -7 on our graph for y. Well, now we know why it's not real, because the lowest y value we have is at -5. So you couldn't have a -7 because there's no part of the graph on that for the y value. Now, we solved for e, so this one was non-real, so we can go ahead and just put non-real in it. Okay, it does not exist. So actually, probably better wording for this one would be no solution. Okay, all right. Now we're on E. E we solved for in our graph. So I'm just going to go ahead and plug in our square root. We solved for the square root of 13 divided by 2. So we're going to plug that in, square root of 13 divided by 2, and it should give us an 8, which it does. But we had a plus or minus because this is a parabola. So again, now we do the negative square root of 13 divided by 2, and again that gives us an 8. And so we have both of those. Let's take a look up here. And those are those two equations, right, or those 2 points right there, okay? And then we have also solved for the g of x equals 9, or I solved for that, and so we're going to plug that in as well, and that is the square root of 7. So just the square root of 7, and that should give us a 9, which it does, and a negative square root of 7, which also is a 9, and you can see those right here, okay, as it adds to it. So I'm going to zoom out a little bit so you can see all the points that we have plotted. And that answers all of the questions for this one. But remember, when it says g of x equals 9, it means you need to go backwards and solve for x. And sometimes that's trickier than others, but you can also use the graphs on your of your equations to help you find the solutions. And you can look on the tables as well. Sometimes that's a little trickier than other, but you can do that in the Texas Instrument as well. Anyway, that ends this problem. So this particular problem, I went ahead and I put all of the points into a table. And then I also graphed them so you could see what it looks like on the graph. And if I was sitting here doing this, I feel like it's something cubic if I'm looking at that. And I say that because it's got that S kind of curve that you get from a cubic function. So I'm going to go ahead and look at these, and I'm going to say, okay, what does 0 to the third equal? Well, 0 to the third equals 0. Well, that takes care of that one. Then I'm going to go, what does 3 to the third equal? Well, that equals 27. So 3 to the third is 27. Then I'm looking at what does -1, and I'm going to put it in parentheses, equal. Well, -1 cubed is -1. Oh my gosh, I think I have the equation. So then I'm going to also go -2 cubed. Well, that is -8 as well. So I think I've got my function rule. So I'm going to go ahead and say the f of x equals x to the third. And now let's see what Desmos says. Okay, I'm looking at this graph, and I'm going to go ahead and plug my rule in, but this is what I've got. This is what I showed you earlier with my table and my graph. So let's see if f of x equals x cubed. All right, I'm going to do this to see what happens. And we have our rule. That just proved it to us. So we are moving on. So as I go through this, I'm going to actually not be doing a lot of writing, but we're going to talk about each scenario. So we're going to start with A. So this one looks like the more gallons of gas you buy, the more dollars you spend. Pretty easy to say that gallons independent is gallons. And dependent is the amount of money you spend. On B, this one looks like the people grow a lot when they're younger, and then they kind of plateau a little bit. So age is independent. Just going to write I, and then dependent is actually your height. Because you're obviously not going to be 5'2" at the age of 1. At least we would hope not. This next one on C is, as time goes by, the ozone concentration does go down. So but the year is independent. And dependent is the ozone. And D is interesting. D is one of those, I've already done C. D is a step integer function. And so as the number of students grow, there's going to be more classrooms needed, but you can only do 30 students. So it's every 30 students, there's another classroom needed. So independent is students. Dependent, capital D, is number of classrooms. And that ends the discussion on this one. We talked about E here a little bit. What are all the possible outputs? Well, possible outputs are just integers. You could only have 1, 2, 3, 4. Those are all the possible outputs. But the inputs are just the number of students. And according to this graph, between 0 and 120. So maybe 120 is the capacity that this particular school can handle. So that ends that question. So I can go ahead and say, just from looking at this triangle, that triangle ABC is similar to triangle ADE by angle-angle similarity. And the reason I can say that is because we have 2 right angles, and then we have a shared angle. So the measure of angle A is equal to the measure of angle A, and the measure of angle BCA is equal to the measure of angle DEA. And because I have 2 pairs of angles that are congruent, I can say that the shapes are similar. So that answers the statement about similarity. As to finishing off A and B, and if you take a look at the shapes, I've got Y over X. Well, that's got to equal the same ratio on the other side because of the similarity. So Y over X would equal N over M, because we have 2 triangles that are similar, so the ratios have to be equal. And then B, we would have N over Y equals M over X, because we're using the corresponding sides from each triangle to compare and set up our ratios. That answers that question. Hopefully those of you who had me for geometry last year got this right all on your own. Thanks. Moving on. I will not be going through and actually solving this once we figure out the mistake, but I am going to help you find the mistake, because it is a common mistake that I've had students all the way through pre-calculus make. When you have a negative on the outside of a set of parentheses, it doesn't just get distributed to the X, it also gets distributed to the 7. It has to go to everything inside the parentheses. So we shouldn't have a plus here. We should have a minus here. And let's see if there's any other mistakes. I think everything else looks pretty good. So now you can solve it the rest of the way. And that ends all of the review and preview help for lesson 1.1.2. Remember, if you enjoy learning from these videos, please subscribe. And also, if you have questions, go ahead and put those in the comments and I will get back to you. And I wish you the best and see you on the next video.